Alrighty. So, here is the book. C++ All-in-One For Dummies. There's 6 books in one. I'm on book 2, chapter 6, about design patterns. Alright. Now we're here. That part. Observers and the standard C++ library. Technical stuff. If you're interested in using templates and the standard C++ library, you can make the subject class a bit more sophisticated by using a list rather than an array. You can do this by using the standard list class. The only catch is that the list class doesn't seem to do well with abstract classes. So you need to de-abstractify your observer class by setting it up like this. So it's one of those things where I can't really tell all the wonderful things. So I have to show the wonderful things. So I'm going to flip the camera. Here we go. So this is what they're saying. You set up your observer class as such. You say your class, observer, your curly brace, start. Your public virtual void, respond. Then you close that curly brace up nice, and you put the semicolon after that because C++ and C and C sharp, you need your semicolons. Otherwise, if you get a single one, you get compile error issues. Yep. Then you can modify the subject class and its methods like so. Class subject, there's the curly brace, protected, list. Then you got your little greater than lesson, but in this case lesson and the greater. Observer, star. So effectively, you're going to end up with a list of pointers to this class. And then, again, the class being observer. Then you got your O list. Then you say public void add observer. Then you got your observer star item. Then you've got your void remove observer, observer start item, void event, void subject add observer, observer start item, O list dot push underscore back item, void subject remove observer, observer star item, O list dot remove item, void subject event, list observer star iter for iter equals O list dot begin iter not equal to, for as long as iter is not equal to O list dot end. You iterate, you can go iterator. Observer start item equals start iter, and then it says item respond. So effectively, you go through the entire list. You set observer item equal to what? So the thing that is item, set it equal to the thing that is at that particular iter, and then you make the item respond happen. Again, the respond is something that was talked about earlier section. So still waiting for that video to process. There you go. regular text, it means I can go back to reading. Note that in the list we're saving pointers to observer. We're not saving the observer instances themselves. That's because by default, the list class makes a copy of whatever you put in the array. If you put E, which creates problems with derived classes because the list copies only the object being stored as an observer instance, not a class derived from observer. With pointers, a copy of a pointer still points to the original object, and therefore the items in the list are the originals. At least their addresses are in the list. Automatically adding an observer. When you have an application that lets its users configure various observers, you may want to create and delete observers based on the configurations. In that case, it's possible to add an observer to a subject's list automatically when you create the observer, and to remove the observer from the list when you delete the observer. To do this, you can call the add observer method from within the constructor and call the remove observer method from within the constructor. But to make this work, you need to tell the object who the subject is. That's easy, just pass the name as a parameter to the constructor. The following code does this. Note that we had to move the subject class above the observer class because the observer's constructor and destructor call into subject. Also note that we made the observer and remove observer functions protected. But because we want the observer class to use these functions, we use a little trick called a friend. We put the word friend followed by the word observer in the subject class. Now the observer member functions can call the protected and private member functions of subject. The code for the complete add remove items application is in listing 6-1, and I already previously went over listing 6-1 yesterday. Not yesterday, but the last time I was doing this. Monday, Tuesday, one of those. I don't really feel like going through that again, so I won't. Okay. Continuing on to the next section. Or maybe. Okay. Maybe. I was a little iffy the last time. Let's see if I'm feeling any better. Okay. So the idea being is that's the subject. It's made friend. So this can now have access to those private and protected members. Part of the protected, so observer is going to be able to have access to the protected and the private things. So count is protected, the list is protected, the add observer and the remove observer, as just mentioned. Then the things that are public or subject, and then event. Then the class observer has protected, subject. Then there's the virtual void respond. Then there is this, I think, is the constructor for observer. It takes subject, it sets the subs equal to the thing that was given to it. Then it calls observer and it gives it this, which is whatever class this is. This is effectively whatever the address is for the thing that you're in, as far as the instance that you're in. And then it has a destructor. You can tell that because of the not, the tilde means not. So not observer, that's a destructor. And then it calls the remove observer this. And then there's class, dog, and it has the public and what the dog does, what the police does. The dog's response, the police's response, the ad observer, how that works. Then how the remove observer works, then how event works, and then the main is just demoing these steps. Okay, continuing on. Okay, so the next part says mediating with a pattern. Suppose that you're designing a sophisticated, complex model of a car. You're going to include the parts, each of which will have its own class. The engine, the electrical supply for technically minded folks, the battery and alternator combined, the radio, the wheels, the brakes, the headlights, the air conditioner, the road. Now see where you can keep up. Read this as fast as you possibly can. When the amount of electricity produced increases, the headlights get brighter. When the engine speeds up, the amount of electricity produced increases. When the amount of electricity produced decreases, the radio volume decreases. When the air conditioner turns on, the amount of electricity available decreases. When the air conditioner turns off, the amount of electricity available increases. When the engine speed increases, the wheels accelerate. When the amount of electricity produced increases, the radio volume increases. When the road angle increases due to going uphill, the speed of the wheel decreases. When the brakes come on, the speed of the wheels decreases. When the amount of electricity produced decreases, the headlights get dimmer. When the engine slows down, the amount of electricity produced decreases. When the road angle decreases due to going downhill, the speed of the wheels increases. Your job is to model all this behavior. Sound like fun? Not particularly. In fact, it's a total mess. How can you model this? Here's the problem. You have a million objects, well, 8, all interacting with each other in different ways. You could try to make all the objects communicate. In the code, making them communicate would mean the most of the classes would have to contain references to objects of other classes. That could get pretty confusing. If you follow all this, the ML diagram in figure 6-1 shows the interactions. As you can see, it's kind of messy. It's a little cleaner now in UML form than in the long-winded paragraph earlier, but it's still messy, and the code itself will be complicated. Tip: when you have this kind of mess, this is one of those things where I'm expecting the comments to be on, but they're not for some reason. Could be. Any chance you want to try and comment or do a chat? I've been having the weirdest thing when it comes to my shorts. The last two, they're acting like the comment should be off, but no. So maybe that just happened and I just wasn't paying attention. Well, I don't want to disrupt the stream. I don't have any way to switch anything if that are off. As far as I know, no one just wants to chat right now. Okay, let's go with that one. Tip: when you have this kind of mess, first try to arrange the things visually to see whether there is a way to simplify it. Figure 6 actually shows your cleaned up version. Looking at this figure, we still get a little confused, but the figure does help us see the connections a bit more clearly. So now we introduce the theme of this pattern. The idea is that when you have a set of classes that interact in a complex way, a mediator class through which the classes all communicate is often the easiest to create. That way, only the mediator class needs to know about all the other instances. The instances themselves communicate only with the mediator. Okay, so time to see things in the book. So let's try that. Okay, so this is success one. Tells us sometimes class interactions can be quite messy. So this is the straight email of all of the classes communicating with other classes. Well, Radar doesn't have anyone to communicate. Let's just start from here. Engine communicates with electric and also with wheels. And then electric only communicates with radiator. And wheels appears to communicate with road and brakes. Brakes doesn't communicate with anything besides wheels. The electric communicates with the radio, and the engine, the headlights, I'm saying communicates, but they're related to, is effective. They have connections with. So, and the air conditioning. The air conditioning is a standalone thing, only connects back to electric. Headlights only come back to electric, etc. Okay? So they're saying that this way, if you change the order a bit, it makes it a little more clean. So if you put the wheels here, the wheels affect the engine and the brakes in the road, right? And the engine is also affected by the electric, but the electric also affects the radio and the headlights and the air conditioning. So it says you can attempt to clean up the email just a bit. All right, back to this camera. Okay. In the example, when there's a hill, the road angle either increases or decreases, depending on the side of the hill you're on, uphill or downhill. The road does not need to know about all the other car parts. Instead, it just informs the meteor of the change. The meteor then informs the necessary car parts. This may seem like overkill. Why can't the road just talk directly to the car parts? The idea is that you can enhance this application later. We may want to add more car parts. Rather than have to go through and hook up connections to all the necessary car parts, you just make a connection with the meteor object. Suppose that you add a new part called an automatic transmission. When the car begins to climb a hill, the automatic transmission might detect this and automatically shift to a lower gear, resulting in an increase to the engine speed. To add this class, you only need to define its behavior and how it responds to various events, and then hook it up to the meteor. You will also modify the mediator so that it knows something about the automatic transmission's behavior. Thus, you don't need to hook it up to all the other instances. Figure 6-3 is the revised UML with the addition of a mediator. Now it looks a bit cleaner. Okay, let's go take a look at figure 6-3. All right, so this is figure 6-3. It says meteor certainly cleans things up. So previous was this kind of just a bit chaotic. This was ordered in a way that made more sense. And then this is having a meteor that can effectively be the spoke of the wheel. So here's the meteor, or the hub. Then the engine communicates only with the meteor, and the road communicates only with the meteor, and the air conditioning communicates only with the meteor. Same thing goes with the headlights and the brakes and the wheels, the radio and the electric. So, back to the reading. Okay. One thing we're not showing in figure 6.3 for the purpose of avoiding clutter is that we're going to remove all the various car parts, including the road, from a base class called car part. This class will have a single member, a pointer to a meteor instance. Each of the car parts then will inherit a pointer to the meteor instance. The meteor class has a member function called part change. This is the key function. Anytime any of the car parts experiences a change, it calls parts changed. But remember that a car part can experience a change in only one of two ways. Through an outside force related to existing classes, such as the driver pushing the gas pedal or turning the steering wheel, or through the meteor instance. If the change comes from the meteor instance, it was triggered through one of the other objects. Alright. Oh, there is chat. I was just wondering. Okay. For example, look at the following steps. Driver pushes the gas pedal by calling the method in the engine instance 2. The engine instance changes its speed and then tells the meter of the change. 3. The meteor instance knows which objects to notify of the change. For this change, it notifies the wheels to spin faster and the amount of electricity produced to increase. Here's another possible sequence. The road has a hill. To tell the car about the hill, the main routine calls a member function in the road instance. The hill has a 10-degree incline. 2. The road instance notifies meteor of the change. 3. The meteor instance handles this by figuring out how much to decelerate. It then notifies the wheels to slow down. So, you can see that most of the smarts are in the meteor class. Putting up a facade pattern. Yeah. Oh, I just don't know. Okay, cool beans. We're going into it pretty good. But I'm also kind of feeling a little bit on the sleepy side. So I'm thinking of winding down this chat for the evening. This video streaming. Because can't seem to not deal with work stuff. Alright. Okay, let's see. Maybe I could. I still haven't quite gotten used to this daylight savings time. Okay, let me set a timer for let's see. I think 10 minutes. Alright, 10 more minutes of reading time and closing out whatever I can for next time because I'm really just feel it. Any message that gets put Under review, stays under review. I don't check those. I don't have the time or the patience or the energy. All right, putting up a facade pattern. In the car parts example, we felt as though it would be cumbersome to have to manipulate the car system by paying separate attention to all the different parts, such as the engine and the wheels, simultaneously. Imagine what life would be like if you had to drive a car while constantly worrying about every little thing. Instead, we created a class called Car Controls, through which you can interact with the system. The Car Controls class is a pattern itself called a facade pattern. A facade is the front of something. It's a French word. The pattern is also a front. It's the interface into the system through which you interact. That way, you don't have to keep track of the individual classes when you add a class through which users can interact with the system. You are using a facade pattern. Tip: you may have noticed what seems like a contradiction in things we've told you and what other OOP, object-oriented people, have told you. Here, we're saying to put the parts in the mediator class. Elsewhere, you may hear that objects must be able to do their own work. But that's not really a contradiction. In fact, the mediator class is handling all the smarts dealing with collaborations between objects. After the mediator instance figures out, for example, that the wheels must spin faster, it notifies the wheels and tells them to spin faster. That's when the wheels take over and do their thing. At that point, they know how to spin faster without outside help from other classes and objects. So it's not a contradiction after all. Take a look at the car parts example shown in listing 6-2. This is the header file that contains the class declarations for the car parts. Sir, this is just a C++ All-In-One For Dummies live stream. There's no show me something going on here. Maybe go find a different stream for that. Okay, listing 6-2 using the carparts.h file. If in def car parts h included, define. So if it's not defined, then define it. How should it include meteor.h class car controls as a forward reference, class car part protected, mediator, star meteor, lowercase m, car part, meteor, star med. So you give that as a parameter, and meteor med, and then void changed. That is function without any, what do you call it? It doesn't return anything. It's class engine, public car part, protected, friend class, mediator, friend class, car controls. Listing 6-2 continued. Int RPM, int rev amount, public engine, meteor, star med, car part med, RPM 0, rev amount 0, rev amount, revolution amount, something like that. Void start, void push gas pedal, void release gas pedal, void stop. Class electric public car part. Protected friend class meteor, friend class car controls. Int output, int change by. Public electric meteor star med, car part med. Output 0 change by 0, void change output by int amount. So it's that we pass into it, into the function change output by. Class radio, public car part, protected, friend class mediator, friend class car controls, int volume, public, radio, meteor, star mod, car part, volume, void adjust volume, volume plus equals amount, void set volume, volume equals amount, int get volume, return volume, class wheels, public car part, protected, friend class meteor, friend class car controls, into speed, public, wheels, meter med, car part med, speed 0, int get speed, return speed, void accelerate int amount, void decelerate int amount, class brakes, public car part, protected, friend class mediator, friend class car controls, int pressure, public brakes, mediator, med, car part med, pressure 0, void apply, int amount, class headlights, public car part, protected, friend class meteor, friend class car control, int brightness, public headlights, mediator, star med, car part med, brightness 0, void turn on, brightness equals 100, void turn off, brightness equals 0, void adjust int amount, int get brightness, return brightness, class air conditioner, public car part, protected, friend class mediator, friend class car controls, int changed by, public air conditioner, mediator med, car part med, I should say star med, car part med, level 0, change by 0, void turn on, void turn off, bool get level, void set level, the get level returns level, the set level accepts a level, the lowercase l as a parameter, class road, public car part, public friend class meteor, friend class car controls, int climb angle, int bump height, int bump which tire, public road mediator med, car part med, star med, car part med, void climb descend int angle, void bump int height, int which, and if. Okay, these classes know little of each other. That's a good thing. However, they do know all about the meter, which is fine. In this example, we use the important small feature of the American National Standards Institute ANSI version of C++. Notice the constructor line in the engine class definition, engine meter med, star med, car part med, RPM 0, rev amount 0. Curly braces. After the constructor definition, you see the colon and the name of the base class, car part. This calls the base class constructor. Then there's a comma and the name of a member variable, RPM, and a value in parentheses, which together form an initializer. When you create an instance of engine, the RPM variable will get set to the value 0. Further, the rev amount variable will also get set to the value 0. Okay. Using the constructor, that's time. So I'm going to just get to the just before the listing success rate, and then I'm going to call it. After the constructor definition, you can C colon and the name of the class cover. This calls the base class constructor. Then there's a comma, the name of the member variable, RPM, and the value in parentheses, which together form an initializer. When you create an instance of engine, the RPM variable will get set to the value 0. Further, the rev amount variable will also get set to the value 0. Using the constructor with an initializer causes the constructor to behave just like this code. And that's the code. It's like this. Is engine meter star med, RPM equals 0, rev amount equals 0. So that's what they're talking about. Next, listing success 3 is the header file for the meteor along with the special class called car controls, which provides a central place through which you can control the car. You may have noticed that we gave the car controls class friend access to the car parts in the carparts.h file. We also included in this file several for declarations. Remember, this class knows about the various car parts classes. This file also includes a class derived from Meteor that provides a general interface the whole system. Okay, well, that's going to do it for the reading, and also glad that people were able to stop by and check this out. I look forward to continuing on with the reading of C++ All-In-One For Dummies later, sometime over the weekend, if not tomorrow. Yeah. All right. Well, thank you. Yeah, thanks so much. Have a good one. Whether it's night, day, what have you, just make the most of it. Bye.